So how do you actually go from all of these split up code files into a final executable? Well, we talked about in the previous video that you have a header files and you have C++ file. And we learned that the header files include things like the menu items in a restaurant, whereas the C++ file would actually hold the recipes. Meaning the header file could be lasagna and the C++ file would have how you actually create some delicious lasagna. So the header file is saying what we have and maybe the ingredients as well, but it doesn't tell you these step-by-step instructions of how to actually make some lasagna. And let's say with an MMO example, the header file has a piece of code that lets you spawn a player, and it could have some ingredients or inputs like what type of player, maybe it's an orc or a human, but the C++ file would actually explain how that type of player is created and then put into the world, and maybe what location is going to be spawned in. But you don't need to know all of those details. You just need to know that you can actually just call this piece of code. So in coding terms, this code here is called a declaration, and this code down here is called the definition. And as a recap from the previous video, why do we actually split up these files like this? Well, one of the reasons is, as a developer, you could just look at the header file to see what you can use. You can learn that you can spawn an actor and what kind of ingredients are needed, but you don't need to know all the individual details in the C++ file. It's a lot faster to just look at the header file to see what you can use. And the other reason is it's actually a lot faster to build your program, because one thing I wanted to explain is that your header files are actually included into multiple C++ files, but your C++ file is not included in other C++ files. And so if you make changes in your C++ file, only that has to get changed or recompiled. But if you make a change in your header file, any of the other C++ files that include that header file will also have to get rebuilt as well. And that takes more time. So now I'm going to show the first step for building your actual program, and it's called the preprocessor. So just before we talked about our header files can actually be included in multiple C++ files, because you might want to use the same functionality from that header file in these other files. You might want to spawn a player in this file and this file. So what does this preprocessor do? What it actually does is it's just a copy paste machine. It's going to copy the code that's in here into these files here right at the top. And it doesn't care about if your code is correct or not. It's just going to copy and paste the code in there. And the reason the compile does that is it's preparing for the second step, which is called the compiler, the compilation process. Now, the compiler only cares about these C++ files. It's going to work on each of these files individually. And its job is to turn this C++ code into machine code, and then to turn it into something called a object file. So what does the compiler do? Remember that piece of code we had called spawn player that was in the header file? Well, you could actually call that in this file here, spawn player. And what the compiler does is it looks at that piece of code and it wants to make sure you've done it correctly. Do you have the right ingredients or inputs into the spawn player piece of code? Are you saying what type of player you want to spawn? Is it an orc or a human, for example? And if you've got any of that wrong, it's going to give a compilation error. It will throw an error at you. But if everything's okay, what it's going to do is put a bit of a placeholder code here and say, hey, I don't care how a player is actually spawned, but I'm going to say that we need something else to fill in this placeholder later. It does that for all of the pieces of code in your C++ file. And then we end up with a .o or object file at the end. So then how do we actually use that implementation code? And by the way, that implementation code would be in another C++ file. For example, here, it could be how to spawn a player is in this other file. So how do we get that actual implementation code to be triggered in a different file? Well, that involves the third step, which is the linker. So where the compiler only cares about individual C++ files, the linker cares about how all these files are connected to each other. So for example, this spawn player implementation over here, what it does is it looks at this little placeholder code here that says, hey, we need some spawn player code here. And what it's going to do is try to link this code together by placing the location of where this code is. And if you want to know the technical term, it's going to be the memory address of the location of this code. We're not going to actually copy the code into here. We're just going to say, hey, this is where the location of this code is, so that you can call it when you're running your program. And then the linker is going to convert all of these files into one executable that you can run on your computer. Now, there's one more important concept I want to explain to you. It's called the one definition rule. And what that means is this definition code here for how the spawn player is actually implemented must be included only once in your whole program. Now, with the compiler, it needs to make sure you won't include implementation code multiple times in one header file. And the linker wants to make sure you won't include this implementation definition code across multiple files. So you want to make sure this spawn player code isn't over here, as well as the exact code is over here. And this rule here is where a whole bunch of your errors can come from when you're building your project. So why do we actually have this ODR? It can be very confusing for the linker to know which implementation to actually connect to. So if spawn player was over here, but it was also over here, and this file over here wants to use spawn player, well, it's very confusing to know which one are we actually going to link to. So by having just one definition, it knows exactly where that is to link to. Okay, so why is this so complicated? One of the benefits of having these three separate processes is called the separation of concerns. The preprocessor only cares about copying and pasting. The compiler only cares about converting your individual C++ files into object files. And the linker only cares about handling all these, linking all these references together. And the second reason is what we talked about earlier. If you only make changes in your C++ file, only that file has to be compiled instead of the whole project. And the third reason is if you got some pre-compiled libraries from another developer, you get a whole bunch of header files that you could use in your code, but the C++ files are actually already machine code. So a proprietary business doesn't want you to see the C++ implementations, but they do allow you to see the header files so you can actually link to the code and actually call the code without seeing the secret code. So the next question is, what actually happens when you double click on this executable file? How does this file on your computer suddenly turn into a running program with memory and logic? And where does all this code you actually wrote live? Where does the spawn actor implementation actually live when you run your program? And that'll be the topic for the next video. If you want to hang out with me on Twitch, I stream 10 hours a day, 7 days a week at Team Vash. We're coding in C++ and Unreal Engine or doing web development. All things coding. Come hang out. I'd love to see you there.